Hi, everyone, and welcome to this week's live with Yora Home. And you guys been asking for a live dedicated to bits, feeds, speeds, and what bits to use and when to use them. So tonight we've asked Garrett from IDC Woodcraft to join us so he can educate you all on bits, feeds, and speeds. Hi, Garrett.
Hello, Sean. How you doing?
I'm doing great. How are you?
Awesome. Thank you for inviting me on here, and
Well,
I look forward to guiding your people as best as I can here.
perfect. Thank you for joining us. Really appreciate you coming here because you are the man for bits.
Oh,
Um,
don't flatter me.
right. So if you want to take off and yeah, start telling everyone what they'd like to know.
Okay. All right. Well, hello, CNC brothers and sisters, as I always introduce myself in the videos that I create. And so I was asked by Sean and the team to talk to you a bit about CNC router bit and how they're used, as Sean just said, and some of the different types of bits that there are out there, and like you said, feeds and speeds. And so we'll dive into this a little bit. Now, there are generally in our world of CNC routers, there are generally three types of bits. So there's your straight cut bit, which is it would be considered an end mill. Uh, Typically, you see them; they have a spiral on them. The other one is a V style cutting bit, so they call it V bit. And then the last one is generally like a surfacing bit, and that's something that we use to clean up the surface of the work surface of the CNC router if you have one that's made of a soft material, and it's also used to uh, surface slabs, wood slabs, and recover botched projects, which I've done many times. So I think we all have been down that road. So one of the first things to think about in CNC router bits is number one is the size of the shank of the bit. Traditionally, in our world, there are two shank sizes. There is the 1/8" shank and the 1/4" shank. So the 1/8" shank is about like that. That's an 1/8" shank router bit, and a 1/4", of course, the shank size is 1/4". Pardon me, because I do have a bit of a scratchy throat tonight. And since most of the Yara Home machines come with 1/8" collets, we'll pretty much address that. But I will say that if you upgrade to a 1/4" shank, then I believe that they have the ability on some of their machines, but I leave that to them. Um, the first thing that we want to take into account with our router bits is the size of the bit. So when we're talking an 1/8" shank, it is a smaller router bit. And so they are not as robust as maybe a 1/4" that many of the routers have. And so that's going to dictate the amount of aggression that we're going to be using when we're carving our thing. And what I mean by aggression is our feeds and our speeds. So we when it comes to the smaller bits, we need to tone it down quite a bit as far as our feeds and speeds. So I'll talk about that in a little while. Let's talk about the different types of straight cutting bits that are out there. So I'm going to come back to this one right here, which since my camera does not do the best job at getting in focus, but you can see there's a spiral going on this bit right here. And so this is an end mill type of bit, and it's a straight cut bit, meaning it's going to cut a square cut in your project. And this is the most common type of bit that we have that you will be using in your CNC projects. And what they're used for is to cut these straight cuts. We usually use them to cut down a level in our projects. So if we want to do a like a stacked text or a recessed pocket in the projects, we will often use these straight cut bits. There are several kinds and they're used for different purposes, but we're going to start off with your upcut and your downcut bit, and we'll talk a little bit about what a compression bit is. So can you bring up a picture of an upcut or a downcut straight cut bit? All right, so what you're looking at here is a downcut 16th inch end mill. So the cut, the actual diameter that this bit is going to cut is a 16th of an inch. And you see at the bottom, it's a straight, has a straight or flat bottom. It's just like that. And so it's going to make your cuts just like that. Now, this is, like I said, considered a down cut. When you're looking at your machine, to think about your bit, you always want to look down from the top of your spindle, and then the bit would be turning clockwise from the top of your spindle. And so this bit right here, as it's turning clockwise, the spirals are going to be going downwards. In other words, they're going to be shearing your wood from the top down into the cut. And the purpose of a down cut is meant to leave you with nice clean edges at the top of the cut, so you don't have something called tear out. If you bring up, and I want you, before he brings up the, can you go back to that picture? Okay, so this is a down cut. Just take a look at the spiral direction on this, and then if you can bring up an upcut and note the difference in the spiral direction. Okay, this is a down cut as well. So again, the spiral direction, if this is turning clockwise, that spiral is turning downward. There's an upcut, and you can see the spirals are in the opposite direction. That's an upcut. And an upcut is the spirals, because of as it's turning, the spirals are going upwards. It's ejecting all the material out of the cut. What is the difference between these two very common bits that you will be using is the big thing about the down cut is it's going to leave a nice clean edge. The bad thing is it's throwing all the chips down into the cut. And so it can compact into the cut, and if you're doing too much in the wrong way, you can actually cause fire. So if you're getting really deep into it and you're hanging out in your cut too long, by compacting that, it's like the Indian rubbing a stick on a stick to create fire on steroids times 10. So in the case of down cuts, you just want to be aware that that is a potential risk if you're not really aware of that. So this is just one of the things to keep in mind. There is another type of straight cut like this that's called a compression bit, where it has a down cut spiral and an upcut spiral. I got to come back to this upcut for a second. The benefit of the upcut is that it can remove material a lot faster because it's throwing the chips out. The downside is it'll leave tear out along the edge of the cut, which an area that you may want to have a nice clean corner on. So at this point, I'll just see if you, Sean, is there anything you want me to address? Is there any questions that may be coming up that I need to get into, or do you want me to continue on?
Right now, I have nothing to add, but we do have a question. How to add a bit, for example, the corn. I believe he means corn milling bits.
Okay.
So essentially the same thing as a end mill.
Yeah. Yeah. So the corn shaped bit. Okay. That one is. I'm going to take a quick look at it real quick. That's the one on your site, and I did look at that before. And okay, so I'm gonna pop on up here. Waiting for it to come up. I guess because I'm streaming, my computer's loading a little slow. So these are generally they have kind of an upcut type of spiral on them, and these are a bit more aggressive in nature by virtue of the gnarliness of them. So one of the benefits with that one is that can remove a lot of material really fast. In the IDC in part of their product line, there's a bit called the Hog, which is called a roughing bit, and that is designed to do similar, kind of the same thing, where it's you can work the bit really, really hard on your material. It can even get a little dull, and it's still going to work and do what it's designed to do. So that's what that bit is designed for. And yeah, just hope that answers the question.
And could you use an upcut bit for roughing and then finish with a downcut?
You can, absolutely. Now, if you're doing roughing's a good talk here, because when you're removing a lot of material with a bit, you're actually working that bit, and so your down cuts, yes, you can absolutely do that. All right, use your upcut to remove the material. That upcut has that upcut spiral. It also has a flat bottom on it, a blade on the bottom of the bit. And so that's going to leave a much smoother finish along the bottom of your project. And then you come around and do your profile to finish that off. So that was a really good question. One of the things I do want to address this, I got a video I created on this that a lot of people sometimes don't realize what's causing a problem. They'll do some cuts around a project, and they'll notice that there's different levels at the bottom of the material, and they can't figure out why their bit is cutting at different levels. And this is small, but it's enough to see. And that's because usually it's because people are using a downcut bit trying to hog out the material. And what happens is the downcut bit is trying to push upward. And when it's taken off the whole diameter of the bit, or a good chunk of it, there's a lot of upward pressure. And then when it starts coming in to do some of the finish cuts, and it's only cutting like a small area of it, there's no more pressure holding that bit up, and the corkscrew of the bit that's pushing itself up. And so it will cut deeper than it was cutting as it's been roughing stuff out. So one of the things to keep in mind if you're switching bits like that is you want to leave a little bit of material. In your roughing cut, you'll have like an offset. What that means is you won't go out to your finish edge, and you'll cut out all your stuff with the upcut, and then come back in and leave just a little bit of a finish edge, and come back in with your down cut, and that'll leave a nice clean cut.
Okay, and we do have another question from a YouTube watcher, it seems. What about feeds and speeds from the corn cob shaped CNC bits?
Okay, so generally, because they're more aggressive and there's more body to them, and these can generally be run up at a higher rate of feed and speed and depth of cut. Now, I want to be careful with that, because the 3018s, we have to go to a different level with the smaller machines, because they just can't handle the forces of a bigger machine. So with the corn cob, you can go up at higher feed rates relative to what you generally run. On machines like 3018s, we'll talk a little bit about feeds and speeds, and your machines. So you want to think, number one, your depth of cut, and you should use a rule of thumb until you get used to how a tool or a router bit is cutting, of set your depth pass per depth, or how deep that bit is going to go before it starts carving. You want that to be half the diameter of the bit. Once you start understanding how that's performing, then you can start changing it and going a little bit deeper. So if you have a 1/8 diameter bit in your machine, then you want to set your pass depth at 0.0625. So 1/8 is 0.125. Half of that is 0.0625. That would be your depth per pass, and then your feed rates for so you have the like the 10-watt spindles. They come up to 10,000 RPM. So with these machines, you generally don't want to surpass 40 inches per minute, because you can actually if you don't you can actually overpower the router itself, and if you're working it too hard and you can stall the router. I've done it many times on mine. Um, and also if the machine, sometimes if we're trying to work too much with your machines, this is an issue, but I've seen it where people have just tried to be too aggressive and the machine just couldn't hold its position anymore. So never exceed, until you're used to it, half the diameter of the bit. Your max feed rate that you ever want to consider using on like a 3018 is 40 inches per minute. I recommend that when you start off, keep it down to like 10 to 20 inches per minute relative to the bit. Now, some bits are different. If you're getting down to a 16th or a 32nd diameter bit, then you definitely want to come down quite a ways.
So when doing multiple bits, upcut to downcut, do you create two tool paths?
Yes. Yeah. You're telling the machine you have to, because you've got to stop that machine to be able to have your bit change. So by virtue of the way our machines operate, we have to create a second tool path, and we have to save it independently, so that you load your first program, which would be your roughing with your upcut, and then you come back in with your profile finish cut as a separate program.
Perfect. Do you have anything else to add on the little 3018, or?
Not at the moment. I can talk about some of the types of, some of the other types of bits and their uses. So generally, right, the upcuts and downcuts are used for, on wood. That's what we start off with. You can move into things like PVC, plexiglass. I don't recommend plexiglass. You hear people talk about acrylic. Plexiglass is flexible. It's still the see-through stuff. Acrylic, what they call cast acrylic, is rigid and stiff, and it's almost like glass. It feels like glass, and so it cuts much cleaner. You generally don't want to use your standard end mills, which we were just talking about and showed pictures of, the upcuts. And never use a downcut in acrylic or any kind of plastic, because you're pushing melted plastic down to the bottom. When it comes to cutting acrylics or PVCs, you generally want to have higher feed rates and use bits that are designed for that, which would be an O-flute bit. And you have an O-flute bit here. I'm not quite sure where they come up with the term O-flute bit. That would be a compression. So let's see if we can find the O-flute. An O-flute bit is designed specifically for things like aluminum and plastics, and they're designed to remove the chip as fast as possible from the cut. Because
can we take a step back for a second?
Sure, yeah.
And someone's asking a question about the compression bit, and they want to know, does it replace the up and down cut bits?
Yeah. Okay. Let's talk a little bit more about a compression bit. So a down upcut bit that's designed. It's a very common style. They work great. You can use that for your projects, and you just have to sand the corners when you don't get the tear out. Can you bring the comment back up, please? Just so I can remember what we're discussing here. A downcut bit, since you're pushing material down, they're not generally designed for cutting out a project. The beauty of a compression bit is it has the downcut spiral on the top of it, and the very end of it has an upcut spiral. And it can work to replace both the upcut and the downcut bit, provided that that the depth of cut, if you're doing a pocket cut, is deeper than the upcut part. There's a little bit of a geometry thing that we would want to talk about when it comes to that. But I really want to answer this question in this way. Why do you want to use a compression bit? When you're doing actual cutouts of a project, the upcut bit will cause tear out at the top of the project but not at the bottom, because the spiral is shearing upward into the material from the bottom. And so it's leaving a very clean cut. The down cut spiral is leaving a very clean cut at the top. On a compression bit, you have the down cut spiral on the top and an upcut spiral on the bottom, so it can actually cut through the material, and you can have a nice clean cut on the top and the bottom. You won't have tear out on either one. So a compression bit can work for it. The thing with compression bits, the bulk of the compression bit is pushing material down into the cut, but you can still use it on your projects. When we talk about these compacting material down into the cut, remember the bit is always moving, and usually the next pass it's making another cut, and then there's plenty of room for the chips to go away, or to evacuate or move out of the way. So you can use down cuts a lot. The compression bits, I generally don't use compression bits unless I'm doing cutouts, and I'll save it for that. So, but it's kind of 6 one, half dozen the other at the end of the day.
Okay. Someone's asking, they cut HDPE, and if they're asking if you have any suggestions for that.
Yes, so we're talking high density PVC. And so you want to use an O-flute bit for that. And the O-flute bit has one spiral on it, and it's a very deep spiral, and it gives plenty of room for the plastic and the aluminum, because they use O-flute bits on aluminum as well. It leaves plenty of room for that to get out of there before it melts back into its cut. And but the whole thing with plastics like PVC, high density PVC, low density PVC, those things cut like butter all day long. There you go. Here's an O-flute, and you see it's got an interesting tip to it, right? It's just coming across, and it's got that one little corner on there, and it's peeling that material up, and what it's trying to do is actually break it into pieces that usually looks like rice coming off of it, and that's the optimal thing that you want to get. So if you're playing with that, you want to adjust your feeds and speeds to a point where these pieces are just popping out of there. High density PVC is generally going to leave kind of a long chip, kind of about as long as the depth of cut. So if you're cutting all the way through in one pass, you're going to have a nice long chip, and they're just going to be spitting out all over the place. Does that answer the question? Did it give you any clarity on that?
We got another question, is the compression bit, does it require a deeper depth of cut?
On the compression bit, at the bottom of the compression bit, let's start with, like I said before, most of the compression bit is a down cut spiral. At the very end of it is the upcut spiral. So pop that question up on the screen, please. And so the depth of cut, you want ideally you want your depth of cut to be deeper than the upcut part of that spiral. For example, on the IDC compression bit, is that compression? Yeah, that's compression. On the IDC compression bit, your upcut is a 0.07 deep. So you would want your initial cut to be a little bit more than 0.07. Now, the two cuts, they actually cross each other. So you can go a little bit less than 0.07. This generally, when a compression bit is made like that, but ideally you want to go a little bit deeper than the upcut on that. And your tooling provider should provide what that distance is when they give you the specs on the bit.
So we got another question. So they're saying good information, but how fast to run your V cutter on plastic?
Okay. That really depends. I mean, because it depends on the plastic that you're cutting. All plastics are different. So we generally have generally we have acrylic, and then we have PVC is what a lot of people do. There's some people that play with ACM, which is called aluminum composite. That's got thin aluminum plates between PVC. But how fast? Bring the question back up, please. With a V-bit, again, it's going to depend on the plastic. But the rule of thumb is, let's say you generally run 20 inches per minute going through your oak or cherry or whatever it may be. When you're running plastic, we're going to up that number. We're going to up that to 30 inches per minute and possibly even 40. You want to, the reason I can't give a solid answer on this is because, number one, it depends on the style of the bit, which you can have a bladed bit or you can have a flat cutting V-bit. And it also depends on the nature of the plastic, the type of plastic that you're cutting. But rule of thumb, you want to be moving fast, because you're generating heat. If you're sitting still or going too slow, you're going to melt the plastic, and the cut is going to start getting really rough because it's melting the inside of that cut. So you just want that cutter to get through that.
Okay. Should I use an O-flute bit for cutting vinyl records? And what speed and bit size should I use?
Okay, vinyl records. Cutting vinyl records, like actually cutting into them and cutting. I'm going to assume this question is taking vinyl records and cutting designs into them. Yes, O-flute bits for that. Absolutely. Whenever you're cutting plastic, unless it's some really weird, strange plastic that has like metal composites in it, or I don't know if it has what's the word I'm thinking of, carbon fiber in it, right? Then you want to go with your O-flute bits. What was the second half of that question?
And bit size.
Bit size. Well, that depends on what you're doing. It always depends on what you're doing. If you're cutting out a large area, you always go with the largest bit you possibly can, right? That's another rule of thumb. Always use the largest bit you possibly can use to do your work, because the smaller the bit, the more fragile the bit, and the slower you have to run it.
Yeah, it takes hours, and when it could take 5 minutes.
Yeah.
So we've been covering a lot about depth per pass, heat, feeds, and speeds, but can you explain what heat does to your router bit?
Okay. So the biggest enemy of heat to a router bit is heat. And the reason is when a router bit is a tool that's doing a lot of work to cut wood, and it's also going really fast. So with that speed, you can create a lot of friction. And that's why feeds and speeds are so important. Now, if you're going too slow, either in your speed or your feed, your bit is going to do a lot of rubbing. And when that happens, that's going to generate heat, and that heat has to go somewhere. And some of it's going to dump into the wood, but it's also going to dump into the metal. Wood, burns really quick, so you'll get nice dark things on there. But when you start dumping too much heat into your carbide tool, or if you use high-speed steel tools or what have you, what that starts to do is break down the crystal structure of the metal. And when that happens, you have nice clean crystals in the metal, and then it starts to get hot and it all starts to deform. And then what that's going to do is just make your router bit a lot weaker, and it's going to start to break down at the cutting edge really, really fast. And at that point, that bit starts to become no good, and it's going to start dumping heat. Once you start to dull it up, the more dull it gets, the more heat's going to dump into the bit, but you're also going to dump heat into your wood, and by doing that, you're going to burn your project where it's cutting.
So is there a quick way to do a kind of a visual test on a bit to see if you're getting too much heat?
Yeah, the first thing is if you see any kind of burn mark, even the lightest color burn mark, that's indicating that your spindle is either going too fast or you're feeding too slow. And generally, we are doing both when we're new. All right. So when you're seeing that, you want to bring your spindle speed down is the first thing you want to do. Right. That's that. And then if you're still getting it, then start bringing your feed up. So the feed is how fast that bit is moving through the material. The speed is how fast it's spinning.
Perfect. Okay. I just figured we should touch on that, and apparently we had a question related to that topic, which worked out really, really well.
Yeah, and that's actually, I'm glad that question came up. Whoever asked that, thank you for doing that, because that's not addressed nearly enough. And in YouTube videos that I've seen out there, it's not addressed. Even I don't address it enough. So I'm glad that came up. I will probably shoot a video on that, because it really, that's one thing that needs to be addressed, and as many people as possible need to understand that.
Perfect. Someone's asking what the best bit for pine is.
Depends if you're doing a straight cut or V cut. So pine is a very soft wood. So pretty much any bit out there will cut pine. The thing to know about pine, though, is pine is it's a fuzzy wood. So when you're cutting it, you're always going to have a lot of fuzz on there. Pine is kind of frustrating. It's a good practice material, but you're going to be sanding on it a lot. It's just the nature of it. It's very loose grain. The best bits, I would recommend down bits whenever you can, because pine also has easy tear out on the edges. And as far as V bits, flat bladed V bits, either one.
Now with pine and some of the softer woods that tend to carry a lot of sap in them, you end up getting, my experience, you can get a lot of buildup on cutting edges.
Yeah,
and that also helps to add to heat into the bit.
Yeah. When you get pitch, pine has a lot of pitch in it, or sap, and so pine is one where that's why they're generally different feeds and speeds for different wood types. With pine, you want to be a little bit faster. Again, it's kind of similar to plastic in that if you're hanging somewhere too long, that sap is going to melt out of the wood and it's going to collect onto the bit, and sap or the pine pitch is brutal. It's brutal to remove. You have to soak just bits in like kerosene, but they actually hold heat. Right, when it builds up, it's like a shellac, and it actually insulates the heat into the bit. So, yeah, good thing to bring up there.
Thank you. Another question: how do you know what type of bits to use? I think we covered it. But...
Yeah. But that's again, that comes from experience. That's why you always want to start off very simple, and just work very simple projects. I have a video out there that says just cut a circle in the square. Yeah, just cut a circle in the square, so you know what you're doing. Just to see, it's just so you can get your feet wet, and you work up.
Typically, you would want to. Depending on the amount of detail or how fine a detail, it's whatever bit will fit to get you said detail. But you would work your way down, because if you have something that's 1/16 of an inch, and you got to get in there with a 1/16 inch bit, you're not going to want to do the whole project with that said bit tip, size tip.
No, that's good. I'm glad you brought that up too, because if you have a lot of material to remove, but you got a lot of really high detail in your project, then if you say, I'm just going to go with the small bit, you're going to be driving around. Your machine's going to be driving around that material forever. You'll want to get as much out as you can with the largest bit, then step down to the next largest and step down to where you're happy with the detail that you're going to get. I have run projects that go from a 1/4 inch all the way down to a 32nd inch. That's 4 bit changes to get that
Mhm.
detail in there, because a 30-second of it, a 30-second bit is not going to, does not have the life of a 1/4 inch bit. So you want to spare those bits as much as possible.
So we have a pretty general question about ball nose bits. So maybe kind of explain their purpose.
Okay. So there's 2 types of ball nose bits. First of all, you generally have the ball nose end mill. So that's basically what you were looking at before, the upcut or downcut with the bit with the spiral. And at the end, it's been ground into a radius. And they are generally used for, we'll say, two different things. The first one is just to add accent to your projects. Like you may do a radius cut around the profile of a sign, or you're doing some raised letters, and at the bottom of the letters, you just want to kind of have that, instead of it being a sharp cut down to the bottom of the letter and it goes flat, you design it so it's a nice little smooth radius in the bottom of around the letters. The other thing that ball nose are very commonly used for in our world is 3D carving. So the reason is because the ball has, it just comes down to a fine point at the end of the ball. And so you'll see 2 types of ball nose. Well, I said there's 2 types of ball nose before. So you have the end mill spiral, and then you have the flat bladed ball nose. But we also have a third type, which is called a taper ball nose, and it's angled like that. But at the end of it, it has a radius on it, and there's different size radiuses, and those are used for 3D carving or doing inlays. And it really depends on how you're using it. You don't always use those for inlays, but they're built like that to be strong, sturdy, to prevent deflection of the bit, because all bits have a deflection in them. Even though you're holding it and it's like this thing is just rigid, but it does have some flex in it, and that they call it tip deflection, right? But we'll use ball nose, taper ball nose to do 3D carvings. And if you do 3D carving, you can do it with, I would suggest you start with an 1/8 inch straight ball nose end mill, like was just brought up on the screen before, and then move into the taper ball nose. Just get some practice on that. To add on to that, you generally want to have come in with a bit beforehand to rough out most of the wood. The software I use, VCarve, is designed to do that, where it'll come in and if you're doing a 3D model, then it'll rough out all the material, and then you can come in with the ball nose, and it's doing very minimal work. And the reason we want to do that is because it reduces deflection, and it will make your 3D carve come out a lot better.
So carbide bits versus HSS is high speed sufficient for most jobs, or are the carbide the bit?
Yeah, so high speed steel, I never use high speed steel, ever. Now the brazed body bits, right? Those are the larger bits that are, the cutting edge is larger than the shank size. That's going to be a brazed body bit, whereas a carbide is brazed onto it. What was the question? Bring the question back up again.
So carbide
Okay,
bits.
okay, high speed steel. Yep. So high speed steel has flex in it. It's not designed to be as rigid as carbide, nor can it tolerate near the heat that carbide can. So carbide has alloys in it that make it really heat resistant. It makes the cutting edge stand up a lot faster. The other problem with high speed steel is because it's a softer metal, it's much more susceptible to heat. It's going to break down on you a lot faster. Think about drill bits that you're using in your hand drills. And I'm assuming you've done that, and you know that as you're drilling your holes, you're holding that drill and you're doing this stuff, you're flexing your bit. And that bit is made of high speed steel. It's designed to have that ability so you don't snap it. If we do that with carbide drill bits, we would be breaking them a lot more often if we're drilling by hand. So overall, generally, I stay away from high-speed steel because they can't handle the heat. They can't handle the high speeds of CNC routers. They just don't last as long.
So the ultimate feed rate and spindle speed produces wood chips and not sawdust.
Absolutely. Absolutely. Yeah. If you are running your machine, this is a good rule of thumb too, that good visual. If you're running a machine and it's just screaming, it's just making noises that doesn't sound right, and kind of high pitch, that's indicative of your feed is too slow. It's cutting through it too slow, or your spindle's too high. And whatever's coming off the machine, if you can pick it up and it's like powder, then you are too slow. You want to have little kind of chips that are falling out of your hand. You can roll around in your fingers like sand. At least that kind of texture. Ideally, a little bit better on the smaller machines. At least it should feel like soft sand. Great point.
Should I use a faster or slower speed when going from softwood, example pine, to hardwoods like oak or maple?
Yeah, generally when you're switching up to a hardwood, then your spindle speed is going to come down, and not necessarily your feed rate. It depends partly like heartwood, and then the because wood's consistency can vary. To answer that, sorry, I'm kind of going off on that. So the question is, your spindle speed will generally come down. You'll probably need to back down your feed rate a little bit, but not all the time. It's the spindle speed that's a big deal on that transition. Now, if you're getting into something like ironwood or something like that, then that's a whole different story.
I hope you like buying bits.
Yeah.
Okay. Yes. Is there any specific bit recommended for in epoxy?
So it depends on what you're doing. If you're surfacing epoxy, you can use standard surfacing bit. Again, you want to move fairly quickly across it, but you don't want to melt the epoxy back into the bit. So you just want to be fairly quick. Epoxy is a little bit different than your acrylics. Again, if you're milling epoxy, you can get away with upcuts on that. But again, ideally, you want to be using your O-flute bit.
Okay. That's good to know.
Yep.
Awesome. So I don't know if there's any other different questions. Okay, well, what's the best speed for 3D carving in walnut or cherry?
Best feed. Again, it depends on the bit. The bit is the first determining factor. The type of style of bit, the size of the bit, type of bit, then what the bit is made of. Right. I'm just going to say you always want to have carbide tools. So the best feed. The next level depends on the machine. So as long as that machine can keep up with the type of motion, sometimes machines come into like a transition point and they have a momentary pause, right? So they have a momentary pause as they make that transition. What you have acceleration, deceleration that has to be taken into account as that machine is moving to a stop point and getting ready to change directions. And so in that deceleration point, if there's a lot of deceleration to almost a stop before it transitions, you want to bring your spindle speed down. Your feed rate would be normally the same. The reason I'm saying this is only because when you stall for just a moment, right, now you're dumping heat into your wood, you're going to create little burn marks in your wood.
So should we be concerned about the heat of a bit after the completion of a job if there are no burn marks during a job?
No.
So,
No, you were going to say something?
well, I was going to say like maybe their bit seems to be a little warm to the touch. I think that might be what they're asking about.
Okay, yeah. A warm bit isn't a big deal. A hot bit is. All right. And a discolored bit, if it's not shiny, if it's not shiny silver, then you've started to burn the bit. Now sometimes you can't tell if it's got coating on it, like the DCL, um, the black coating that you may see, because you can't tell burn in there. The other thing I do to test a bit, I learned this just by habit in my machining days, was I will just take the bit and put my finger on the point, and I'll just see if it's still a point there. It'll actually catch my skin, and I'll also feel the edge. The edge should still be feeling kind of like a razor blade. And if you're losing that and you can just kind of roll your finger past those points, then your bit is probably getting dull. But a little bit of warmth in the bit is not a big deal. So when the metal heats up, that heat is actually traveling through the metal, and it's going to transfer into your router. And so if it's not getting too hot, and that heat is able to keep traveling out of the tool in the machine and distribute out into the framework of the machine and into the air, then it's not that big of a deal.
Okay. Someone's asking if you can go over the basics of surfacing bits and how best to use them.
Okay, surfacing bits are a good one. I love this question because so surfacing bits. So this is a surfacing bit right here. Actually, bring a picture up because you can see it a lot better. And see if we can get the one that's laying down, and maybe we can come back to this picture here. Okay, so this is one that was introduced at IDC. It's probably the only 1/8 shank inch surfacing bit on the planet. I looked for them. People were asking me for them. I couldn't find any people who made them, so I had them made. So a surfacing bit is classified in your software generally as an end mill, unless the software actually has a place where you can say this is a surfacing bit. So surfacing bits generally have 2, 3, or 4 flutes. They can have more depending on the nature of it. In CNC routers, that's what you'll find: 2, 3, and 4. And a surfacing bit is designed. What we use them for, number one, is to level off the spoil board of your CNC router. When you get a CNC router and you have a wooden top on it that you're going to clamp your projects to, you want to smooth out that top so that that is parallel to the motion of the CNC router, and that's what we call surfacing the spoil board. And so it's kind of like what's going on here. But you see what that bit is doing is actually removing a pretty wide, a lot of real estate at one time. So a surfacing bit, if you're putting a fresh piece of wood down, it may not be level to the motion of the router, and even a slight deviation. Let's say you're going to do a V carve on a sign, and a V carve, you got some letters in there that, I love my mom, and have whatever it may be, and that piece of wood may be thinner on one end than it is on the other, and you're doing a V carve. Well, as that V carve comes around, that router is working on an incline. And so as it's making this cut, that V groove is getting deeper and deeper and deeper, and the project's going to come out looking really bad because on the one side, the cuts are really deep, and the other side, they're very shallow. So the surfacing bit is designed to clean that up, get that level so your project looks good. So you use it to prep your material. And when you have a case like that, you say, oh crap, I ruined my project. You come back in and surface settle that down, and you've recovered that piece of wood, and now you can recarve what you originally were carving. The thing with surfacing bits is they have a much wider diameter cut. And so the router is turning, but there's something we call radial velocity. And so at the outer edge, that surfacing bit, since it's a lot wider, those flutes, the cutting edges, are traveling a heck of a lot faster than they would be inside, at the 1/8 shank diameter. And so when it comes to surfacing bits, your spindle speed generally needs to come down a bit and your feed rate needs to ramp way up. So, and you can't take a whole lot of material off at one time. In the case of this one from IDC, you can take up to a 0.05 with that, right? It's a small bit, and that's what we can max out at, and that's got a safety factor built into it. I mean, it can actually go up to 0.1, but I built a safety factor into it because the smaller machines sometimes can't handle that workload that is being put on it. That's the other thing, because it's taking off so much material, you got a much higher workload on that bit. The biggest thing with surfacing bits, when you're using it, if you start to see little burn marks along this is the track of the bit, and we'll just say this is the slot, and you start seeing little burn marks in the corner of the slot, your feed rate is too low, and you got to bring that feed rate up, because what you're doing is you're starting to dump heat into that cut, and anytime you see a little burn mark, that means you're creating too much heat. High feed rates and lower spindle speeds on those machines and shallower depths of cut.
You mentioned general rules of thumb for speeds and feeds, but where does the rigidity of the machine come in?
The rigidity of the machine comes in all the time. So the rigidity of the machine is going to be a factor of the quality of the cut it's going to produce. So what this question means is, a machine is so strong, and it once its rigidity level, or the strength of it to be held firm, is reached, then things are going to start to shake around. They're going to vibrate because the machine is surpassed its rigidity, and that vibration is being caused actually by the bit trying to make a cut, and it's sending it's basically harmonics or resonance is going back through the machine, and it can't hold that. The amplitude of that harmonic, and so it starts to shake around. It's not as rigid, and that's going to bounce back into the cut, and it's going to be real choppy. So if you're seeing things like that, like choppy cuts, and you're going, this is a brand new bit, these cuts look really choppy, then you probably want to tone down your feeds and your speeds and see how that works, because that may be what's going on. So I'm glad that question came up. Hats off to the person that asked that question. Do you feel like I explained that one well enough?
I think so.
Okay.
A lot better than I would have. The rest of my question is the long, skinny, sharp ones. What are they for?
Long, skinny, sharp ones. So I guess we're looking at yours on your website.
I guess.
So these are engraving bits. Okay. These are bits that I would use these to carve out my grandma's handwritten recipes. That's the application that I would use these, and I would do it on wood. These have flat blades on them, and so they're very, very narrow, long, pointy, look like hypodermic needles almost, or blow darts, right? Because they come down, they're so thin as they come down, they will they become a little fragile at the end. So you want to be really gentle with those. We can break the tips off of those really quick if we're too aggressive. That's why depths of cut become important. So we're looking at a 30-degree engraving bit from IDC Woodcraft. So it looked like yours were 20-degree.
I think they're 30. I'm pretty sure they were 30-degree. Maybe.
Okay. And those are 1/4-inch shank then, right?
No, those were 1/8. I don't. Yeah, those were the 1/8 shanks.
Okay. Okay. Yeah. So you see the project that is in this image here, right? This is what this type of bit is going to do, right? So you can do some beautiful, beautiful, amazing work with those long, pointy ones. But a project like this thing took 2.5 hours to carve. That's not all of it. But so this is what you would want to use it for.
Yeah, as you said, they're really great for detail, but the tips are very fragile. And if you don't have your clearance when moving the bit around, you're going to knock that tip off, and then that bit will now be useless, as
Yeah.
you won't get the detail anymore.
Yeah, I will say this though, with a bit like that, and you're doing with such a fine point, you need to bring your spindle speed way up. Uh, because it's such a fine area that it's working at, you want that to be able to get as much of that material out. Um, and because it's so thin, the heat is going to literally transfer away from that tip really fast. So you can this is a little bit different technique on these things, but you want to keep cut shallow.
What would you recommend the speed and feed to write? I guess that's 6 thousandths deep in
6,000.
plastic. And what bit would you use?
Okay, in plastic. So we'll assume maybe acrylic. 6,000. So that's like engraving. I would be going with a diamond engraver if I'm doing something like that. All right, 6,000 is that's machining standards, like metalworking standards. Um, so if you have to cut, then 6,000 steep, whoo, baby. Depends on the cut. I would say just go with a diamond engraver if you're going that shallow. If you got to cut it, clearly I would just go with well, I don't know. I've never actually cut something that deep. I always engraved, even in the machining world, when we're that shallow.
Mhm.
Oh, I love questions that challenge me like that. Good question. So yeah, diamond engraver, or um, you would probably want to use a bit like we just saw,
Mhm.
the engraving bit.
I don't know if they come a little more narrow.
Mm,
Um, can you explain step over when entering bits and mill versus ball nose bits?
okay, leave the question up, please, on this one. So this is a two-part question. So step over. That's a really good question. So when your router bit is passing through the material, it's making a cut. And step over becomes a big deal in surfacing bits. And I didn't mention this, that you want to have a high step over in surfacing bits. So let's talk about what step over is. You have the diameter of the bit is actually making a cut. And then it's going to come back and cut over in the next, like next to that cut. Well, the bit, let's just say it's a quarter-inch diameter bit, or 1/8 inch diameter in this case. And so this is an 1/8 inch wide slot. And then the bit has to come back over and start coming to clear out the next leg of that cut. Well, the bit is going to move over a certain percentage before it comes back to the cut. So the percentage, let's just say you have a 1/8 router bit. It's making a 1/8 slot, and you have a step over of 50%. Then that means that the bit is going, when it comes back over to its next pass, it's going to move over 50%, which is a 1/16 of an inch, or 1/8 inches 0.125. It's going to step over 0.0625 and come back. And technically, a 50% step over is half the diameter of the bit. So it'll make its cut, it'll move over half its diameter and come back through its cut again. So your traditional step over, you want to work with 40% on most of your straight cutting bits, O-flute bits, your end mills, and what have you. Surfacing bits, you want a 70% step over. You want to come over and take off. You want this bit to, the most of the diameter of this bit to be doing work, as opposed to like end mills and what have you. Partly because if it's not, then remember the bits, when they're not cutting, they're rubbing. And so you want to minimize that rub, especially in a bit like this that has a high velocity on the outside. So that was the step over part. When entering bits and mill versus ball nose bits. Okay, this is part 2. End mills are flat cutters, so they're shaped like that. The ball nose has a ball and is shaped like that. So an end mill, you have a square cut, so you can literally take that box and step it over a fairly high distance. Traditionally, like I said, is 40%. So as a straight end mill, you make your first cut, you step over 40%, 40%, 40%. With a ball nose, you have that little radius tip. If you step over 40%, what you're going to do is get a cusping effect in your wood. And so we have a much smaller step over to compensate for that radius. And so in a ball nose, your traditional step over would be 5 to 10%. If you're using a ball nose for like 3D carving, we're talking 5 to 8%.
Hmm.
Did that make sense?
Made sense to me.
Okay. I hope the viewers got that.
I think they helped us. I think it did. Can you read that? I can read that out loud. It says, "I'm a newbie. Can you explain feed rate and spindle
Yeah.
speed, please?"
Yes. Absolutely. So the feed rate is how fast the router bit is moving through the wood while it's doing its carving. So think of like miles per hour or kilometers per hour. That's a feed rate. It's a rate of speed that something is traveling. The spindle speed, and by the way, this is a very beginner's question, and I want no one to ever feel foolish for asking. So thank you for bringing that question out to the table, my friend. Okay, so spindle speed is how fast that bit is turning in the machine. So you have what we typically in the R home units, you have a spindle, and the spindle is the motor that's turning the router bit. And so that has a variable speed control built into it. And so you as you're designing your project and you're setting your router bit standards in your software, you're telling it for this bit, this is the speed rate or the RPMs that the bit is going to be turning at. And then the feed rate, you're going to say we have to do a certain feed. Now, the thing with feeds and speeds is they are married together to create an optimal cut and the longest life out of your tool. So if you have a spindle speed that's too high, like it's turning at an RPM of 10,000 max RPM on the machines, and the feed rate is too low, then it's basically spinning really fast through the cut and just barely taking off anything out of that cut. And the drawback on that is you're going to put a lot of heat into your tool, and you're going to wear out your tool really fast, and you're going to burn the wood as you're working through it because it's just creating heat. Whereas if you have too high of a feed rate, then you're putting too much work against your bit. The feed rate is how fast it's moving. You're putting too much pressure against the bit, and you can break the bit. And so that's why we talk feeds and speeds, because that is going to determine how well your machine is going to cut, how long these bits are going to last. And all materials, your different species of wood, your acrylic, aluminum, high density PVC, MDF, they all have different densities, and that means they have different feeds and speeds. But you generally want to start off with your basic units that are given to you. Your home provides some basic information. I got some out on every bit on my website. In the full description has that information. The IDC Woodcraft app has information. So anyway, the feeds and speeds, they are going to they're there because your different materials require different settings to get the best cut and to preserve the life of that tool. That was a long explanation for something I probably could have cut in half.
I think feeds and speeds was one of the harder things for me to comprehend when I first started with the CNC routers.
Mm-hmm.
Is the terminology for the name of bits pretty much universal in brands?
Yeah, so there are, most of them are, right? A spiral bit is considered an end mill. Um, your brazed bits, which are like, where to put it, the surfacing bit that has brazed carbide tips on it, so it's a different material here. I use 4140 steel on these. I have them use, and um, so these are brazed cutters, but generally we call them, flat edge cutters or brazed tip cutters. And yeah, generally the terminology is the same across the industry. No matter what machine company you're dealing with, they're generally going to know a V-bit is a V-bit. It's shaped like a V. That's just why we call it a V-bit. A ball nose has a ball on the end of it. The end mill has a spiral on it. Sometimes we'll say something like that's in the mill. The surfacing bit is a surfacing bit. It looks like that. Keyhole cutter is a keyhole cutter, and it cuts a keyhole. A hole. It looks like a keyhole that you'd put those old time skeleton keys in. Good question.
Mm-hmm. Plunge rates, minimum and maximums for bits previously mentioned.
Yeah, every bit's different. Generally, okay, but it is good. Plunge rates, when you're dealing with surfacing bits, I always set my plunge rate super low, because with the surfacing bit, you ideally don't want it to plunge in the material because it doesn't have cutters in the middle of it. So it's going to bury itself under the material. It's going to burn. But plunge rates, generally plunge rates are about 33%. If you're going in straight plunge, they're about 33% of your feed rate. When I ramp into cuts, I adjust my plunge rates to the regular cut rate. So to the person who just said, "What's the difference between feeds and speeds?" People at that level may not know what plunge is. So there's two things that are going on as your router bit is coming in to do its work. The first one is it actually has to get into the material to start cutting it. So when it's coming into the material, it's plunging in the material, and then it switches over to its cut. So plunge rate is the speed at which it's plunging into the material, which is we can set differently in our software to the normal feed rate of cutting. And we'll want to do that when, for example, a down cut bit does not have a bottom cutter on it. And so we generally plunge in a little bit slower to give it time to just get wood out of the way. But the rule of thumb, plunge rates 33% of your standard feed rate. If I'm ramping into a cut, I automatically change my plunge rate to the feed rate, because it's coming in like that anyway, and it's just going to swoop into a flat cut. Yeah. Make sense?
That was a good explanation, I think. Someone's asking if they can use Dremel bits in their CNC router. They have a 35,000 max speed rating.
Yeah. So the Dremel bits, I'm gonna guess that you're talking about using burr bits, which on Dremel, a burr bit has lots of little grooves in it, and so those can be run up really fast. Those are meant for grinding away metal and stuff. There's no reason you can't. Those are 1/8" shank as well. But I don't want you to think because it has a higher RPM rating that they put onto it doesn't mean it's going to provide better cuts, or you can crank up the feed and speed, because every tool works different. And the tools we have on CNC routers are designed for CNC routers, generally designed for wood or plastics or aluminum. You want to know what bits you're going to be using for what. But at the end of the day, if you want to slap a Dremel tool in there, I can pretty much promise you're probably going to break a few before you figure out how to do it, because I don't have feeds and speeds for Dremel bits.
Are bit extensions adapters safe to use for bits that don't have enough length of travel to reach the intended depth of cut?
This is pretty rare. I very rarely run across people wanting to work with extensions. And so an extension is basically, it's a piece that you're going to stick up into the router. You're going to lock it in. At the other end of it, it's got a hole in it where the router bit can slip into it, and you can somehow clamp it on there, and therefore you've extended the reach of that bit. I generally do not recommend you doing that, because what's happening here is you are clamping on the surface that's clamping on the surface that's extended way out, and you can, if it's not made properly, if like the extension is not made properly, you're going to have what they call run out, where the bit is actually going to be, I'm exaggerating, but it's going to have a turn like this, and that run out is going to throw vibration into your equipment, and when you throw vibration into your equipment, that vibration is either going to be absorbed into the machine, or if it's not that rigid and it can't handle the vibration, is going to pass it back down into it and make it shake even more. And before you know it, that machine's shaking all over the place. Can go back to, I think there's another part in that question I wanted to answer. Adapters, okay, so I'm assuming they're talking about the same thing. Now, there are something called, well, you have collet adapters, right? Like at IDC and many places, they sell the 1/4 inch to 1/8 inch collet adapters, and it's a quick and dirty way to switch from a 1/4 inch shank to an 1/8 inch shank. But that's not necessarily meant to extend. It's adapters is really a convenience thing to save you from having to swap out a collet every time. Yeah, so that's the collet adapter. Yeah, I will say these are convenience things, but I would strongly recommend you can use these, but I would always go back to the maker, or find, if you want to use an adapter, I would try to find a collet that's the size that you want it to be. You'll have a much better grip on the thing. There's much less opportunity for the bit to slip in the thing, because again, you're holding the surface on the surface, and you have to sometimes crank it down even more than you want to. And you were going to say something?
Yeah, I was going to mention something, but you ended up covering it. But I'd like to thank you for joining us and explaining all this feed speeds and bits to our audience. I'm sure they appreciate it very much.
Yeah, absolutely. Absolutely.
Okay.
I'm always willing to come back on and gather a bunch of questions, and we can handle them as we move along. But yeah, I'd be more than happy to come back on, help you guys out, talk to your guys, and give as much education as I can, because at the end of the day, I'm here to help you make a good project and to teach you everything you need to know as fast as possible, and stay safe at the same time, and help your router bits and your last as long as they can, and get the best out of the machine.
Well, I'm sure they all appreciate that. Thanks again, Garrett. Thanks for watching, everybody. And until next time, have a fun time CNCing, guys. Bye.